All right, so looking at the end, or the third page here of the Unit 2 review, questions 12 and 14, there are some questions on. Remember that you're graphing these, so like y is less than or equal to 4. There's no x there. That's just a horizontal line. So I'm going to go up 1, 2, 3, 4. Horizontal line here. Is this solid or dashed? Solid. It's got the or equal to. So solid line here. Y is less than or equal to, so I'm shading below here. So kind of right in there. The other one, y is greater than x. If I put in 0 for x, I get out 0. If I put in 1, I get out 1. It's just like the simplest linear equation you can do. Just 1 up 1 over 1, y-intercept of 0. This one, solid or dashed? Dashed line. So dash, dash. Like so. Y is greater than x. Okay? So I'm shading above here. And what you should be able to see now is the section of the graph where you have both red and blue, which would be right in here. Does that make sense to everybody? And if they asked for a point, anything in that shaded area would be fine. Anything on the blue line next to the shaded area would be fine. Anything on the red line doesn't work because the red line itself is dashed, not included. For number 14, we've got y is less than or equal to 1/3 x plus 2. So I'm looking at a vertex of negative 2, 0. Going up 1 over 1, 2, 3. Up 1 over 1, 2, 3. Up 1 back, 1, 2, 3. 1, 2, 3. Solid line, it's got the or equal to. And y is less than, so I'm shading below. And then we can compare that with this one. Absolute value of x, literally just right here, and then going down 1 over 1. That one should be solid. Its y is greater than. So we end up with this bow tie shape, right? In between those two. So I'm looking at like here, everything over here, and everything over here would be my final answer. Does that make sense to everyone? Any other questions from the stuff that I had you kind of finish on your own? Were we good with number 10 and 11? If you're not sure about anything on 10 and 11, feel free to ask now or later. Yeah, LJ. Yeah. 11b. So 11b, list all the labeled points where g of x equals f of x. This means looking for, oh, you said 11b. That's 10b. There's 11b. Shade where g of x equals 0 must exist. So I'm trying to look at g of x and compare it to 0. So at the beginning, negative 1 is below 0. So we're just going to imagine that this line is 0. At 0, g of x is negative 1, so that's below. But 3 is above. 2 is above. Negative 2 is below. So I see it switch here and switch here. Does that make sense, everybody? So again, instead of comparing it to another function, you're just comparing it to a number. Okay, go ahead and grab them. Any other questions on 10 and 11? Ethan? Just do it. Go ahead and do C. And then which one were you going to ask for? 10, D, and E. All right. So now letter C here. Same thing, but comparing f of x to 3. So if this is 3, you can do f of x is, and you could do the numbers too if you wanted to, that f of x is 0, f of x is 2, f of x is 4, 4 is above, f of x is 5. If you would rather put the actual numbers themselves. But again, we're looking for where it switches below, below, above, right in here. Somewhere it would have had to cross 3 when it went from 2 to 5, or sorry, 2 to 4. And then real fast back here, D and E, these were a little bit interesting because you're talking about where it's above or below on a particular line. So 10D, list all the labeled points that are solutions for g of x is less than f of x. So I'm looking here, g of x is below f of x, and it wants points on g of x. So this is below, but there's no labeled points. This is above. This is below, and there's 2 labeled points here, C and D. Both C and D are on g of x below f of x. And the second part, E, is just the opposite. Where is it above f of x? Well, just f, right? F is the only one on g of x where g of x is above f of x. While we're on it, what did you guys get for B? Where's the g of x equals f of x? Okay, I heard a couple different things. Which one was it? B and E, right? Those are where they cross. There'd be another point right here, but they don't have it labeled, so we can't use it. B and E. And then for C, labeled points for F for x equals 0. I'd given some of the classes the hint that this is the y-intercept. Right? X equals y, or x equals 0. Which point on f of x is a y-intercept? And in fact, that's the y-intercept for both equations, isn't it? All right, so we've gone over just about everything there except for the last page. So let's turn there and look at the last page. Now this one has a lot of questions that require you to use the quadratic formula. There's actually not that many on the test that require you to use the quadratic formula. But for those of you that might be worried that you're going to forget what the quadratic formula is, having talked with the other teachers, 99% sure that we're just going to let you use the basic calculators. There's no reason for you to need a scientific calculator or anything, and this way we have plenty of these. No one has to be worried about not having the right calculator. So you can use a calculator, just a basic one on the test. We also had a variety of formulas on the test, on the previous test, that you guys hadn't had to memorize. We're not going to make you memorize them now. Rather than trying to list all the ones up on the board, you can all have a 3x5 note card. You can put whatever you want on this 3x5 note card. When you take the test, this is what you're going to have as a reference. Put whatever you want on it. Then when you take the test, you're going to turn it in with the test. Does that make sense? That way also I can check and see, oh, you missed all those questions. It was because you wrote the formula down wrong. That'll help me a little bit when I'm grading as well. So you'll turn this in along with it. If you have your own 3x5 note card, you can use that. You can write front and back, but nothing more than a 3x5 note card. Mostly that's so you guys don't write yourself pages and pages of notes and then waste time flipping through your notes trying to find the one thing. Just put the important formulas, the minimum, the things that you are most worried about forgetting on here. Does that make sense? If you would like one right now, raise your hand and I'll give it to you right now. I'll have a pile out as well. You guys can get them later if you want it later.
It was dug into my homework.
Fine with me as long as it sits on this.
That's my nasty, actually. Yeah.
All right, did everybody that wants a note card get one? Again, I'll have a stack of them. If you are writing on it and you're like, oh, that's not what I want, and I don't have another one, just come and ask. I'll get you a different one. So, when we get to the quadratic formula on this back page, which we will, you're welcome to write that quadratic formula down. You're also welcome to write down any of the other formulas that we go through. I'm going to help you out with number 15 real fast. 2x squared minus 7x minus 4. It tells us to factor this or to solve it, and this one we're going to solve by factoring. To do that, I can either do guess and check, which is what we've been doing mostly this year, saying, okay, I know that I need 2x squared, so it's going to be a 2x times an x, and then I can try different ways to make negative 4. Could be a negative 1 and a 4, could be a 4 and a negative 4 and a 1, could be a 2 and a negative 2. I'm guessing, since I want negative 7, a negative 8 and a 1 would be real great. So I'm going to do 2x plus 1 here and minus 4 here. So that then when I check, because this was my guess, I check 2x times negative 4 is negative 8. 1 times x would be 1x. Negative 8x plus 1x would make the negative 7x that I need. So this should be right. Now, that's guess and check. The Math 2 classes this year are learning the area method. This is what they're doing most of the time when they're having to solve stuff like this. The area method says, okay, I need a 2x squared, and I need a negative 4, and then these two boxes need to add up to negative 7x. So the only way to make 2x squared would be a 2x and an x, and then I have a couple options for making that negative 4, and so then I could essentially guess and check. It's the same process, just organized a little bit more. So I could try negative 4 and 1, but if I do that, I get negative 4 and 2x, negative 4x and 2x, and that doesn't make the negative 7x that I need. So then I could try again. Maybe switch those places, put the negative 4 down here, the plus 1 up here. That way I get a 1x and a negative 8x, and that does add up to the negative 7x. And you can see again the 2x plus 1 that we came up with here, the x minus 4 that we came up with here. Just another way of organizing our work, if that helps. So now, once it's factored, I set each of those equal to 0. So 2x plus 1 equals 0, x minus 4 equals 0. This one's nice and easy. Add 4 to both sides. X is 4. This one I do have to subtract 1 from both sides. And then divide by 2. And I get x is equal to negative 1 over 2. Those would be my two answers for that. Does that make sense to everybody? This one I wrote the answer down here. I want you all to try 16 and 18. I'll tell you right now that 18 is the easier one. 16 is almost exactly like 15 that we just did there, but you do have to get it equal to 0 first. So 3 minutes for you guys to try 16 and 18 right now. If you want to start with the easy one, start with 18, then do 16. If you're stuck, check with the people next to you, check with me.
Shut up. Dude, I was like, I didn't know what I was just like, I was like, let me just get the paper real quick. I was looking for this one.
17 we'll talk about. You multiply it all the way out, and then you get it equal to 0 by subtracting that 3. The trick is that one
I
doesn't
did
have
the definition for the, what's it
and I'm
called?
only going to show you
For the
one with this one
numbers.
right because it doesn't cost that much. That's what I remember.
You doing with a smoothie?
Alright, let's go. Sorry, can't
Well,
read
she
that
wasn't just like, I have to study it.
So, this is another way of organizing and getting this.
I can read it.
You don't have to do both of these, you just have to end up here.
No, 'cause I
But once you end up here, you have to solve it to get the actual answer. And that's this process. All right, so most of you are done with 18. Some of you are done with 16. Let's go over those. For 18, anybody want to shout out what multiplies to negative 21 and adds to 4? 7 and 3. Is everybody good with that? Specifically a negative 3 and a positive 7. So I'm looking at x plus 7, x minus 3. Again, you can use that area method. You can use the diamond method. You can use the cross method, whatever you are comfortable with for factoring. Once you've got that, though, both of them equal to 0. X is negative 7 or positive 3. How could you check those to make sure that they worked? Plug them back in, make sure it equals 0. Whether you plug it in here or to the original one. 7 squared would be 49. 4 times 7 would be 28. Negative 7, so that's negative 28. Minus 21. And yeah, 49 minus 28 minus 21 does equal 0. So you would do the same thing with a 3, make sure it works. Back to 16. Most of you figured out that you do have to get it equal to 0, so we're subtracting 11x from both sides. Subtracting 4 from both sides, so that we end up with 3x squared minus 11x minus 4 equals 0. And then you're really factoring the same way we did over here. You can do that area method if it helps. Say, all right, this has to multiply to make 3x squared, which means it's going to be a 3x and an x. And then this needs to be negative 4. So I'm going to try maybe a negative 4 here and a plus 1 here. That would get me a 3x minus 4x. That does not add up to the negative 11x that I need. So let's try again. Try swapping them. What if we put the negative 4 down here, put the plus 1 up here. That would get us a 1x and a negative 12x. Negative 12x plus 1x does make the negative 11x that I need. Does anyone have any questions about this area method? Again, if you want like me to explain any of the different factoring methods at any point, let me know. So here then I have 3x plus 1 times x minus 4 equals 0. Solve both of those. This one, x minus 4 equals 0, would just be x equals 4 when you added it to the other side. This one though, 3x plus 1 equals 0. You do have to subtract 1 from both sides and divide by 3. Gets us x is equal to negative 1 over 3. There's our two answers. Does anybody have questions about those? So this is the method, one of the methods that we're using when we're solving trinomials. What about 20, where you don't have an x squared and an x? You've got an x inside a squared here. There's a faster way to solve this using square roots. I can add 5 to both sides. X plus 4 squared equals 11. Then because the parenthesis squared is by itself, I can take the square root of both sides, giving me x plus 4 equals plus or minus the square root of 11. Don't forget the plus or minus. Then I can subtract 4 from both sides. X is equal to negative 4 plus or minus the square root of 11. Those would be my two answers. Now the trick here is x equals negative 4 plus or minus the square root of 11. If that square root of 11 simplified, I should simplify. This one, 11 doesn't factor, so I'm done. I want you all to try 24 right now, and I'm going to tell you right now the square root simplifies. So again, 2 minutes to try 24. Give that a shot. I'm telling you that it does simplify.
You hear it? Huh?
So instead of squared, it's b squared minus 4ac.
You're still like for
Yeah, that's what you did so far. So then take the 24 and break it apart. See if there's any numbers that you can take out. Remember how you like factor it out, look for pairs of numbers. So did this make sense? Try that same here, adding 7, you can square root of both sides. Again, try to stay on top of this, sorry.
Sorry, I have a question.
Yeah.
Are you gonna go over unit 4 before Thursday?
Not before Thursday. We're gonna go over unit 4 on Friday, probably.
Okay, when is the last day to take tests? When do you want?
I would really like it done this week.
Okay. The only reason is because, like I said, I can come Thursday after school.
So, I mean, if you could come in at lunch and ask some questions, I've gone over this so there's a video of all this on there already.
Okay. Yeah.
And this is what I went over during the extra day when I stayed after school for those 2 hours.
No,
But I know you missed that.
That day I was in Mr. Ford's going over unit 5.
Okay.
So yeah, I mean, I was like, do I do now or do I?
So if I would again say watch that video when we went over most of it in class. Stick around, look for the problems that you have, that you need help with. You come in and ask questions. If you need to take it on Friday, like after school, you can do that. But again, it's probably going to be the easiest if you just take it during class on
Yeah,
Thursday.
I'm gonna try and push for that, whether it be coming in at lunch like tomorrow or something, or today. Right now it's hard because in history, if we go in and do work, any work, we get extra credit during lunch. But then obviously I need to do this, so I'm gonna talk to her. I'm gonna be like, okay, I gotta do this. So if I go maybe like after school to do work for her, then she'll be there, Wednesday after school.
Yeah.
So I think I'll just do that. Yeah, I'll most likely. Are you gonna be during lunch tomorrow?
Yeah, I don't have any. I don't have any meetings during lunch. I have meetings before school and after school tomorrow. But not lunch. Yep.
Thank you.
You're welcome. All right, let's take a look at 24 now. See how we did. So real quick here, for 24, first step. Dom, what was our first step to solve this one?
First step, I added the 17, or maybe 7.
Okay, add 7 to both sides. Leaves us with x plus 2 squared equals 24. Kaivo, what's the next step? The squared. So what are you, tell me again, what are you doing with the squared? So we don't actually want to multiply this out. We do want to take the square root to get rid of that squared. And that may have been what you were saying. I just want to make sure. Okay. So square root of both sides. X plus 2. Don't forget the plus or minus. Square root of 24. And then we've got two options as far as what you do next. Let's save the simplifying of the square root of 24 for just a moment. And let's get the x by itself. So that last step then, Caitlin, what's the last step here to get x by itself? Subtract 2 from both sides. So that leaves us with x is equal to negative 2 plus or minus the square root of 24. And that's kind of what we had to do on the previous one. This one I can go a step farther. I can take that square root of 24 and simplify it. Because 24 is 4 times 6, 2 times 2, 2 times 3. We have a pair of 2's that can come out. The 2 times 3 will stay inside as a 6. So I have negative 2 plus or minus 2 root 6 is my actual final answer. Does everybody see and recognize and understand that last step? If a square root simplifies. That's where we're starting next semester. When we come back after Christmas break, we will be going over roots of all kinds. Square roots, cube roots, fourth roots, all kinds of roots. That's where we're starting next semester. So now, let's take a look at 25. This is another one where you might want to put this formula on your note card. It's back there. This is factoring cubes. Sums and differences of cubes. This is a sum of cubes. The reminder for you guys is if this is something cubed, and this is something cubed, it factors quite nicely into the first thing, same sign, same opposite, always positive, so x plus 2 times the first thing squared, opposite sign, two things multiplied together, 2 times x, always positive, last thing squared. Again, that's on the back wall, the poster there. We went over it several times. This is a low priority. It may only, if it shows up on the final, it's going to show up one time. Okay? Not going to show up a bunch, but I'm going to do it with you right now because it also will help us practice the quadratic formula. And that same thing may show up once or twice on the final. So now, to finish this, I'm going to clean it up just a little bit. X plus 2, x squared minus 2x plus 4. This one, the x plus 2, I can get an answer for right away. That's my real root. X equals negative 2. This one will never factor. I have to use the quadratic formula. So a is 1, b is negative 2, c is 4. I would plug all those into the quadratic formula. Yes. Right there. Or are you wondering where it came from here? This one? Or this one? This one comes from setting x plus 2 equal to 0 and solving, just subtracting 2 from both sides. Again, this one should always end up with a nice either whole number or fraction, but a real answer. It's this one that we're going to have to use the quadratic formula on. And that means, that quadratic formula, x equals minus b plus or minus the square root of b squared minus 4ac, all divided by 2a. So now, I can take this, plug in a, b, and c. So x equals minus b, so negative, negative 2 are positive 2, plus or minus the square root of b squared, so negative 2 squared, minus 4 times A times C, all divided by 2 times A. Clean it up. 2 plus or minus the square root of 4. 4 times 1 times 4 is minus 16. 2 times 1 is 2. 4 minus 16 is negative 12, so 2 plus or minus the square root of negative 12 over 2. That 12 factors 4 times 3, 2 times 2. Got a pair of 2's. We can do 2 plus or minus the set of 2's that we took out. And then it was negative, so that's an I, 2I. There's a 3 left over, all over 2. And since all 3 of these are divisible by 2, I can simplify it all down to 1 plus or minus 1I root 3. So there's my 2 imaginary roots along with my 1 real root. Does anyone have any questions on that? Again, that's a low-level priority. If you've studied everything else looks good, can practice that one just in case it shows up one time or so on the test. I'd practice the quadratic formula once or twice too. But again, that's not one of the main pieces of the test, like the absolute values. You want to make sure you can solve absolute values first. That's going to be more heavily featured on the test. 26. 26, 27, 28. This is just, can you make a composite function? G of f of x. Second period, when we were going over this, a lot of people were getting them backwards, putting the wrong thing in. So here, the one on the outside, G normally of x, we're going to say g of something. So here it's g of something is that something squared. The something that we're putting inside is f of x. In this case, it's x minus 1. Sorry, that wasn't what I wanted right there. I was going to write f of x there, and the x minus 1 here. But it's the same thing, right? F of x is x minus 1. So what I should have as my answer is g of f of x is equal to x minus 1 inside the parentheses squared. I want you to try 27 and 28 knowing that these two mean the exact same thing. This g of f of x means g of f of x. These are the same thing. It's exactly what I did on 26. 2 minutes for you to do 27 and 28. And go. Now again, walking around last period, I was seeing a lot of people doing it backwards. So, I'm going to write the two possible answers here. Is this either absolute value of x plus 3, or is it the absolute value of x plus 3? How many of you think it's the first one? How many of you think it's the second one? And we have a bunch of people that didn't vote. So class, if you're taking f of x and putting it inside g of x, it's this one. The absolute value of x takes the place of the x that was there. So not this guy, that's f of g of x. That's putting g of x inside f of x. We want to take the absolute value of x. Again, if you write it like this, g of x, g of something is equal to something plus 3. If that something is f of x, and f of x is the absolute value of x, that's what we should be looking for. Absolute value of x plus 3. Does that make sense? Be careful not to do it backwards. Same thing for 28. 28, you're taking f of x, putting it inside g of x. So you should have 2x plus 1 squared. This one, it goes all inside. That would be our answer for g of f of x. All right, that is everything you need to know for Unit 2.